Hey folks, Brian here. Today I've got a bunch of things to show you. I've enhanced the FFMpeg utility tool that I've been working on, the FU tool, to now create thumbnails out of videos. So today I'm going to show you how to read and write files, decode and encode PNG image files, and also use the TrueType, the font, the face, the draw packages all together to render text on those images to create a thumbnail. So let's get started and support the channel by checking out the description below. So I've got everything in this function called create thumbnail. And the first part of create thumbnail calls FFmpeg to extract one video frame. I also do a trick of applying a video filter and scaling that image down to keep it under 2 megs, YouTube's thumbnail restrictions. Like in previous tutorials, I showed you how to use OS exec package to create a command and get its output. The side effect of all this code was to create a file called output file name. And now we need to open that file to render text on it. So I used the helper function called IOUtilReadFile to open the whole image and put it in a byte array. I could also use os.open, os.read, and all sorts of other functions, but this puts it in one line and puts it in a byte array, so I don't have to worry about closing file descriptors or having defer statements. Really handy. Maybe not useful for really big files that might not fit into memory, but this is good enough for this small 2 meg image. Next up, it's really that simple to decode the PNG file. We just call PNGDecode, and we use bytes new reader to translate from a raw byte array into a reader interface satisfying type. For PNGs, at the top I also include an import image/PNG, which has a static init function that will be executed and register the PNG format. It may not be needed if we use the PNG functions directly, but just in case, remember to include that import. Now decode also has a corresponding encode, and after we draw this text on the raw image buffer, we're going to take that image buffer and encode it using PNG.encode. Now down here I've used the regular OS package, OS create, with a file descriptor close function, because it's no longer just simply reading and putting it into a byte array, it's also writing it, encoding it, and doing other things, so I had to split it apart. So that takes care of how to read and write PNG files using IOUtilReadFile and the PNG functions. Now this is where it's going to get a little bit more tricky. The main point is all these images are just two-dimensional arrays of data for every single pixel. Each pixel has a color, and we're just going to manipulate these two-dimensional arrays. So first, using the image we got from the PNG.decode function, we're going to create a new RGBA image. An image has a certain bounds, a width and a height. So we use the image bounds to create a new RGBA buffer. Then we use the draw package's draw function to draw into this buffer the full entire image. So we draw into the rectangle of the whole image, the bounds. We take the image and we draw it from the 0 point of that rectangle and fill it in. And draw.source means we just copy the exact pixel value into the image buffer. Another option is allowed to kind of overlap the alpha transparency bits so that you get a transparent look. But here we're just copying the image in. So that was how you copy a PNG image into a buffer. But now I create another buffer called the BG image, the background, and that's the black background behind the text. And here you can see painting into the image is really just going through the coordinates of the x and the y axis and setting them. Here I've set it to black because the image I'm creating is just the black squares. So what we've done so far is we have one buffer with the PNG image. The second buffer is the same size, but just completely black. Soon we're going to combine those to draw the background of the text. Next, we've got to grind through more boilerplate to get going. And here we have the IOUtil read function to read in a file called obratronbold.ttf. TTF is a file that has data about the curves, how to render the text, A, B, C, all the curves, the dimensions, the ascent, the descent, the baseline, all the data that is necessary to render text on the screen. I just downloaded this file off the internet, and it's sitting in my local directory along with fu.go. So I call ioutil.readFile, and that returns once again a byte buffer. Now I use the TrueType package to parse that font data and return a font struct. After that, I use the TrueType function with newface with a bunch of options like the size and with anti-aliasing enabled so that the text doesn't have rough edges, and I store that in a face. And finally, we're almost there. I create a font.DrawType. This DrawType is going to be used to render the text. And the source is the font color, so it's going to be white, as you saw in our thumbnail. The destination is going to be that PNG buffer, and right now, if we were doing this thumbnail, it just contains the train picture. And face is the whole font we just created. So now, let's move on to the 3 steps. Now, so far, I've showed you how to open the file, decode it into PNG, encode it back to PNG, and write it out. And that's what this code currently does. I have certain lines commented out. So let's run it. And we're going to run it on this festival file here. So with what I've explained, it just creates the RGBA buffer and renders the picture. I did create the black image buffer, but I didn't do anything with it. Now we're going to uncomment certain parts of the code to show you how it works. So first up, we're going to calculate a line of the thumbnail text. We're going to get the bounds. A bounds is a rectangle with an XY and another XY to describe the rectangle. And everything in these font packages, they use a different way to store numbers. You're going to see a lot of 26_6, which is a 26.6 fixed point. 26 bits are used for the whole part, and 6 bits are used for the fractional part, and they're combined together for 32 bits. So you can add fine, but certain operations like multiply, there are functions there to use it, so you don't have to worry about the bit manipulation. But bound string, this is going to return a rectangle with 26.6 and an advance in 26.6. And the bounds is obviously the outline, the square containing the text, so you can get the height. And the advance is how much of the width it takes. So if you do hello, the advance is after the letter O, where we can advance and then type more text. Now we use some more of the fixed package to add some padding. So here you can see I created a point object, which is just a container for 2 values. There's image.point, but here we have fixed point. It's the same thing, but it uses the 26.6 format. Then we use the add function on the point to add padding, and we multiply the padding by 2 using the fix.I function, which takes an integer and converts it into an integer of the format 26.6. So the 26 bits are used to store that number. The fractional part isn't really used. So now we have finally a box that contains the text, contains enough room for the text, and padding around it. Now this code below, we're going to actually start drawing the black background. And this is some calculations we've done here. I've used the round function to convert from 26.6 world to regular integer world that we're used to. And this function here just computes where that black square is. And I'll leave that as an exercise to the reader. And now we can use this draw package with the draw function. And there's no documentation on these parameters really. Let's see. What does the documentation show up? Oh, this is commented out, so it won't show any documentation. Draw calls draw mask with a nil mask. So as far as I understand it, first you need to draw into a rectangle. This is going to be our PNG image, so we're going to draw into that. Next, this is the boundaries of that rectangle that we're going to draw in. We're going to draw into a small rectangle of the bigger image. Now what are we going to draw into it? We're going to draw in the BG image, which was black. And we're going to draw starting from 0, 0 of that image. So it's going to draw a full black rectangle. The BG image is the size of the entire image. It's so big, so we don't have to worry about running out. And then now we use draw.over for no real reason, because it's not transparent. But it doesn't matter. So now that we've uncommented it, let's run it. So we've created a rectangle and we've drawn into the RGBA buffer. So now you can see the black rectangles are showing up. And the BG balance calculation here was just shifting the rectangle down each line, and the width was set to the advance plus additional padding that wrapped around each string. And we used the bound string function to get an initial idea of the box. Okay, now we've got to shift toward adding the actual text. And adding text does not use the draw package. If you recall, it uses the font package with a DrawType. And this DrawType, the way it works, it does use, again, all that 26.6 stuff, and you draw at a position of a dot. And the text is drawn upwards from the dot, and the dot is like your baseline, so all the letters go above the dot. So here we're resetting the dot back to the left. Then we're moving the dot down a bit for the top padding and the text height. So each time we render some text, the dot does advance, but we're manually resetting X back to the front and moving it down a little bit. Otherwise the dot would keep moving right and the text would just keep appending. So you can manually manipulate the dot, or it'll move on its own. And finally, the moment we've been waiting for after all this setup, we call d.drawString. So now let's run it. And there you go. Now the text is drawn. Finally, we've manipulated that RGBA buffer where we originally got the PNG and put it in the buffer, we're now going to encode that buffer into a PNG and write it to a file. We create a file which supports the methods on writer, and we call encode with that writer, and then finally we close the file to finish any writing operations. And that's really all there is to it. In short, we learned how to open and close files so we could get the output of the FFmpeg file. We learned how to do PNG decode and encode to take that PNG and convert it into raw image data, where each pixel had a value to represent its color. Finally, we entered the strange world of 26.6 and used that with the TrueType packages, the font packages, and we used bound string to measure strings, and we rendered the text at a dot that was moving, but we reset the dot manually. So that's all there is to creating a thumbnail, manipulating image buffers, and keeping track of all these different coordinate systems and the 626.6 stuff. But once you get a hang of it, it's not too bad. So I hope this helps. Thanks for watching. See you later. Bye.